In the last video, we saw how to get the gradient of a curve or a straight line using the graphical method. This video helps you to get the gradient of a curve given its equation and using differentiation. We're going to take a look at 4 examples with different levels of complexity. So let's get started. The main steps we'll be using to get the gradient of a curve would be step 1, to differentiate the function with respect to its variable, in our case it's x, and then step 2, to plug in the value of x at that instant into the derivative. Let's take a look at example number 1. Given f of x is equal to half x squared minus x minus 2, calculate the gradient of the equation at the point -2, 2. So we are going to use the power rule to differentiate this function, which is basically looking at the power of x of each term, multiplying that term by its power and then subtracting 1 from the power. Okay, so for the first term, which is half of x squared, we'll multiply it by 2 and then we take away 1 from its power. And then we do the same thing for x, which has a power of 1, and then we take away 1 from that. And for the last one, which is the number 2, we can see that it doesn't have an x, so in that case its power is a 0, and that's why we multiply by a 0. Then we're going to go ahead and simplify this function, and we get our derivative, which is x minus 1. Now when x is equal to -2, we substitute -2 into the derivative function to get -2 minus 1, and that gives our final answer -3. Example number 2. Given the function f of x is equal to 2x minus 1, calculate the gradient at x equal to 4. Now this one is interesting. So let's take a look at the solution. We start by differentiating the function once again. In this case, it will simply be 2. And then we need to now plug in the value of x. The value of x, which is 4 here, cannot be substituted in the derivative function. So that makes the derivative still being equal to 2. It cannot be substituted because it's a constant and there is no place to even substitute the x into it. If you look at this graphically, right, this is the graph of y equal to 2. And no matter the value of x that you choose and you map onto that graph, you would see that the y value would still be 2. So when x is equal to 4 or even any number, it will always be a 2. Okay, example number 3. The graph of f of x is equal to -x squared plus 3x is shown alongside. Use the graph to estimate the gradient of the tangent to the curve at the point where x is equal to 2. Calculate f prime of x, and then lastly find f prime of 2, and hence compare with your estimate in Roman 1. Alright then, so they want us to first of all estimate the gradient of the tangent to the curve where x is equal to 2. It means we're going to draw a line touching just the point x equal to 2. And then we choose 2 points on that straight line to work out the gradient. So my points here would just be 1, 3 and 3, 1. It is best practice to write these points aligned or stacked on each other so that you don't make mistakes when you're calculating the gradient. We'll start by finding the change in y. So we do 3 minus 1, and then we also find the change in x. From there on, we can now find the gradient, which is the change in y over the change in x, and that gives us -1. Okay, Roman 2 says we should calculate f prime of x. So first of all, f of x is equal to -x squared plus 3x to the power 1. I just put the 1 there so that you can easily tell the power of x. Then we're going to differentiate this once again, and then we simplify our function to get 2x plus 3 for the derivative. Okay, there's that. Roman 3 says we should find f prime of 2. It means they want us to substitute 2 into our derivative function, right? So when x is equal to 2, f prime of 2 will be negative 2 times 2 plus 3, which is equal to minus 1. And what do we notice? It gives us exactly the same answer as before in Roman 1. Example number 4. Given that y is equal to the square root of x minus 8 over x squared, calculate the gradient at 4, 1.5. A pro tip for this question would be for you to rewrite it in such a way you'll be able to see the powers of x, okay? That will help you differentiate more easily. So if y is equal to square root of x minus 8 over x squared, since square root is the same as a half, we rewrite it as x to the power half minus 8, x to the power minus 2. Okay, we now go ahead to differentiate this by multiplying by the powers and subtracting 1. We simplify the function to get half x to the power minus half plus 16x to the power minus 3. Just for simplicity's sake, I'm going to rewrite the function back into its square root form before substituting the value of x. So this would be 1 over 2 square root of x plus 16 over x cubed. Now, when x is equal to 4, right? We need to plug in 4 wherever we see x so that we get 1 over 2 square root of 4 plus 16 over 4 cubed, of which you can use a calculator to simplify. Dy by dx being equal to 1/4 plus 16 over 64. Simplifying further and adding up, our derivative would be 1 over 2. And that's basically it. Okay, if you found this video helpful, please subscribe. I'm trying to get to 100k. And watch the next video on the rules of differentiation right here.